will be doing some more bytecode. Um. Okay. So what I need here is basically I need to support all the expression operations, and after we do that, we'll probably try to add variable support, although I also need I need to probably move type resolution from from parser to another step, because I need to make globals be treated differently, and that's not possible if we resolve immediately on lexical analysis. So either I take the type resolution and I move it to the compiler, the code makes sense, or I have yet another pass. I don't know if that's really necessary though. We'll have to think about it, but yeah, I'm not sure. It's probably better to have a resolution thing, because then at compile time we can do some like optimizations, because we already know the type. It's not like we have to guess it. Although I guess you will know the type anyways before the thing. I don't know. I mean, probably the safest thing is just to have another step before compilation and after AST is parsed. Currently that's in the parser, in the parsing stage, but yeah, that makes it not work for globals, because parser is sequential and globals are late bound. So, and that just means that we want globals. So for globals, we want to allow uh, reference if like there's global, right? One, and I guess for all constants that's also true. And we have some func, right? S1 should be able to access this global, which is after it. But since parsing is sequential, it doesn't know that this exists. So we can't do type resolution at that point, as it has to first see this thing to see the type. Or for example, if it was like int, right? Or even like this, it has to see this to see its type. In this case, it's obviously just implicitly an int, and then it can evaluate it. And yeah, that's even necessary for compilation, because globals will be in the data segment. Will just be they will just be offsets to the data segment. Okay. But for now, I think I'll do a short one today. For the same reasons as the last time, because I want to go to sleep. We'll see if it will be a short stream. Recently it wasn't, even though I wanted it to be. So maybe this time it is. I think what I need to do... First I need to definitely add all the opcodes. So we have subtract, multiply, divide, modulo. So this is line up, unup, and then identifier up, right? Unum will be opcode negate, or rather logical negate, right? And then also negate. And for identifiers, we'll just have assign, Basically, we just take those four and say assign this. Because we can't even need support really. So we'll do it like this. Return here. Print here. And then just to really have like declare and other stuff. I'm not doing variables yet today, I don't think. Okay, and now in old runtime, let's just take all this. Oh yeah, also I guess there are more because there's like less than, greater than, equal to, not equal to, less or equal to, and greater or equal to, right? And then there's also and or, right? Data not constant because those can be non-constant, right? Okay. I guess let's add support for all those in the compiler. So this will be data. Bind up this here. For now, let's compile an opcode return at the end. But yeah, I guess this can just be a knob. Yeah, subtract is special because it can either be a opcode negate or an opcode subtract depending on if it's a binup or not. So we'll just do this for fixing that, and here we'll do it like this. Identifier ops, right? And then unop special one likes token type negate, right? It's logical negate, and it's here, right? So we'll do it like this, maybe, or no, because yeah, okay. Yeah, I don't really know if I need the other way around though. Yeah, so for ands and ors, I'll do something different, I think, but and all Lex token types will just be opcodes here. Now your runtime value is true is something that I want. Runtime value is true. This thing, right? Have it here. This will mark them for a static for now. This is opcode, opcode. Yeah, I should mostly do it for binaries. So the only exception is N and OR. I will say to do handle short cutting for and or and the as a bytecode jump question mark. That's something that the compiler book did that I just don't know yet what I really want. And I have to do that, right? Yeah, that makes sense because yeah, it would pick the value. Yeah, so basically it would like do this, right? Because the code is like eval A or whatever. Eval B, and then it's like add, right? And this pop B, pop A, right? And then Origus, let's do and, right? That's what it does. But here is like if true, go to exit or something, right? Exit. Then this should push the ball, right? Pop B, pop A. And this should say... Actually, this should be like if false, then push... It's like push false and go to exit or something. So it'll be pop or peak A. If false, then pop A push false is like how this would work, right? I'll leave it here. E.g. Like how this bytecode flow works. That's how it works. And then this is like the full fetched operation. And we just return the result here, right? And this default I indent because I don't need it to be its own scope, so it just looks cleaner. I could also do this, but I think that's unreadable. It's like more consistent, but then it's like, oh, I should indent this or something. So to preserve indentation and cleanliness, I just unindented. Okay. So now all I need to do is eval binup like this, right? Eval binup runtime A B upcode, which is yeah, it's here. So like this, and then runtime push value runtime eval binup like this. This is all we need for binups, and then I guess what we could do. No, that's fine. I will just grab all of them like this. I'll just say don't. Tabulated, we'll say case, we'll add the colon. That's really it. And then I will separate those two to their own thing. Oh no, actually it doesn't even need anything because there will be another opcode for short circuiting. Right now we don't search the circuit, so it's a big no-no. Add short circuit, right? So we'll say actually this is in progress, right? Say add lineups, unary ops. We're not doing the identifiers yet, because that requires variables, and we will not have them today. Okay. Unops. Okay, let's do unops. They should be simple. So yeah, a lot of the compiler code is just like the runtime code, but like done differently. So instead of being directly working on IST, we first compile this to like compressed bytecode, which does the same things eventually, or similarly, but it's like more assembly like rather than this high level objecty thing where you just work on the tree. Function call. No. So what I need here is re-up. Okay. We'll add. So there's eval. Say static runtime value eval unop. Kairos runtime. And we'll say the same things as here, but only just one thing, right? And we don't have to evaluate because that's already done by the bytecode, right? And then upcode is here. Or no, yeah, it's here. And then a eval value is just replaced with a. This. The runtime value result is held here, and then we return the result like this. It's actually a runtime error. Instead, like this. If result type equals this, right? If our binary operation result should have been called by compiler but wasn't. Right, we'll say that. Also say that here, unary operation result. Okay, and now result value is just result, like this. Runtime here. Because if we already had errors, then there's no point in printing more. I think it would cascade, like this cascade would, like here it would cascade from this error to this error implicitly. It's not really a point to that. Okay. Yeah, actually, even before variables, we'll do control flow. So jumping. Unobs are almost done here. Upcode. This is like negate and logical negate. We'll just pop one value and we'll eval inop, unop, unop. And that's it? Question mark? that's pretty much it. We just need to also compile all the opcode, so just in a sec. Runtime pop value. I feel like I missed something, but I don't know what that is. I'm thinking about too many things because I already started thinking about control flow stuff, and that made me lose my flow here. Ironically. Okay. Runtime compiler. So let's just operation type the opcode. So for unop, we just say we'll just push this opcode. So this is operation type to opcode, and it will be statement binary up, and this is a bind up like this. And then unary up. It's just unary up. It's just the expression. And it's like this. Now what I would want to say here probably is, yeah, so let's do this. Opcode like this, right? Opcode. And now if opcode equals runtime, right, this is opcode, not like this. It means compiler error prog. It's a bit weird that we only use like Kairos program in compile expression, honestly, but whatever. As of right now, we didn't need more. This would be like invalid unary op type. Say, oh yeah, and also statement like this. So I wasn't wrong when I wrote that. Likely a compiler, but say like this. Okay. Let's test that. Let's say if hello equals hello. Right? Should say 1. Invalid opcode is what I get. And that's in runtime, I think, right? Should really add more stuff to the error ring. But what is this opcode? It's opcode 2. It's return. Yeah, that's not an invalid opcode. It's just return equals return true. It just means we terminate it. We'll just say go to exit for now. That's it. Returning will later just return the call stack. If we are in a function. I will also use it for like async returning, I think. Yeah, and we see 1. So we have expressions back. When I say like 3 times 3 times 3 times 3 plus 3 plus 3 divided by 3 or something. Let's maybe simplify this a bit. So this should just say 10, right? If I'm not mistaken. It does. Cool. We have binary expressions. We have Let's see if we have subtraction then, right? I've actually never checked. It does. And now if I actually negate this number, how does it work? Ordinary operation result. See, that's interesting. Eval unup, subtract. Oh yes, those are incorrect. So this is upcode negate, and this is upcode logical negate. Okay. Could we cut that? And this is now 10. It seems correct, right? Now we have 8, and then we would have 10 minus 10. This is actually kind of silly, because this is technically, instead of it being a constant of minus 10, it's a constant of 10 that is later negated on runtime. This is pretty silly, so we'll want to fix it eventually when we have optimizer. But I don't know. Let's do if statements, I think. So we'll have like jumps. We'll have upcode jump, like jump if true, right? Jump if false, right? So what we want for now is just if true, then we want to print this, right? Right now we don't, because if is not compiled. So let's just compile it. Right? Now what we need is like segment push jump segment say opcode, right? Because it requires an opcode. Also have void segment patch jump segment. So all of those segments jumps. Do I even use them outside of compiler? So if I don't, maybe I should actually pass the runtime directly. But I think I do use them sometimes, yeah. Jump, and this would be the take the offset actually. So here we would say segment push U8, right? Segment opcode. I'll say segment push U32. Segment 0, right? I will return this. Say segment get read type segment offset U32 and will be our U32 pointer, right? And what you want to patch it to is our jump offset. Now our jump offset will be a jump offset. Okay, we'll do it like this because we can. just interpreted as signed. And our jump offset is it's like whatever the offset was, plus 4. So this is like the original position. So this is the source of the jump. This is where we are after we read the jump instruction, right? And we want to go to the target, and our target is here, and it's segment, arena, position is where we are. This is where we want to jump. I'm pretty sure, so we can just say this. Could even do this. It's fine with me. I mean, maybe I'll leave this as was because that's a bit more readable, right? And then I could also even say jump source equals this, right? Jump target is this, and jump offset is like target minus source. Say it like this. I think we have to use this 32 here. Maybe I actually push IU16. Nah, that's pretty limiting, I think. So what happens when you subtract two U52s signed and C? And say like this, and that should work. Should do it. Right. Okay. And now what it does is it compiles the expression of the condition, right? If condition, right? Actually, let me first implement the opcodes because those are really simple. Opcode jump. Hey, it's funny how simple the fucking VM is, like the runtime is. It's like this all here is just moving the IP by jump offset by the jump offset, and the jump offset just is read runtime read U32 runtime, right? And we'll cast it to S32 as it's implicitly casted here, right? Jump if true, right? Okay. If false is the same. Really, this is just like a jump always. Right. And in this case, we'll say pop value. It's like this. And now if runtime value is true, value. We just increment, right? Just like that. We'll do the same here. And then we'll negate it. That should do it. We could also do long jumps, which instead of like adding an offset, it would set the IP. It could work, but I don't know. Not sure if that's useful. Calls will be absolute addresses for sure. Yeah. I was also thinking that the stack, instead of being this kind of thing, would probably want to make it. I don't know how to do it though. And I would want to make this dynamic. So instead of it being a union thing, I would just want this to be a dynamically growing arena to which you can push any size you want. That will allow us to push strings on entire strings on the stack, like structs or whatever. And the way to and I don't know how we would pop stuff, because we'd have to track the sizes of each element on the stack. So we could have like U32 size stack, max stack or something. Which could be a really large number, right? And then arena stack like this, right? And we could push and pop stuff, and it would just work. That might be something. Is I don't really want the runtime value to be this thing. Ideally, right? I would want it to not have to be tagged. I would want it to just have what it needs to work. Right now it has way more than it needs to. Because types don't change dynamically in this language, so there's no need to have it on runtime. Okay. And the compiler now, we'll say jump. Say segment push jump program code. Say upcode jump if true, right? We'll say then, and we'll say else, right? So we'll compile pop expressions. So that should allow us to have pop, right? True. Or else then, right? And now here we would say segment patch jump segment code. Program code, right? Right. Okay. And just patch this jump to be here, and we'll patch then jump, else jump. This one will be Alright, let's do this. I think that does it, right? It doesn't though. I need like an exit jump. Exit jump. Say else jump. So else jump is created after the condition, and it's patched here before the else, right? And the exit jump is actually compiled at the end of the then statement. and it patches to the exit, right? That should work. The else jump should jump if false, right? Should do it. I think. And the reason it doesn't work is because we need to support scopes, and scope is really a very simple thing. It's just an iteration over every statement of the scope and compiling it in a linear fashion. So this is, what is this? This is statement, right? And then this is scope. And this is statements, statements. Oops. And just STMT, like this. We'll compile that expression. Just like this. Then we have the if statement. False. It says else. Great. Let's do the while loop then. That should be very easy. Because all this needs to do is set while. So we'll have while condition, and we have the while scope. I want to order them in the correct fucking ordering eventually. I don't know. Don't know how to do it yet. Compile expression. Compile expression. Bit confused. One thing I need to do. This also should be compile statement because we only have statements. But speaking about only having statements, I think it would be better if we had expression as its own thing, right? Have every expression type there and just have like a struct expression statement expression like this, right? I'm not doing that yet, but I think that would fix some of the issues with would make the error checking for the compiler better. An error checking of the C compiler actually, because then implicitly we know that expression is supposed to return a value while a statement is not. A statement doesn't return a value. It did before because of the return and how propagation worked. That shouldn't need to happen here. I will do that later, I think. And okay, let's do while loop. And all this needs to do is like... this is funny because... So we need to say U32 like loop start equals the program code. So when we have the patch jump, let's say patch jump explicit, or rather maybe I do push jump EX, right? Would say U32 address. Good jump offset, right? Let's make this a static. All of those can be statics. We don't push anything to segments during runtime, as far as I know. Right, and now what I need is any eggs. So let's say this is our offset. I guess that just means that we push a jump. No, because patching a jump always uses the current target, right? Here the difference is we compute the jump offset of the offset plus 5 to the address. Plus 5 because we also count the opcode size. Plus 4 because we don't count the opcode itself. 5 because we also count the opcode size. Okay, yeah, that's fine. That should be good enough. And now what this means is that every time... Okay, let's clean this up. So this is just segment push jump EX. And the opcode is opcode jump to the loop stored. Right. And we have segment push jump program code. Can I just have this as its own thing? Segment equals program codes, right? And now every instance of this can just be replaced with this. Also, yeah, that's something I thought about when I was in bed yesterday. I need to free instead of clear. It's also in parser. Here arena. This is free arena. So we are never using them again. We want to fully free them. Okay, and here say opcode jump if false, right? We'll patch this. So this is E32 exit jump. We'll patch this patch jump segment push jump code exit jump like this. So we want this exit jump to point here, and we want this jump to go at the beginning. And actually the condition needs to go before the jump. Right. Okay. I think I should do it. Right. How many things we don't support yet? We don't support those. We support this, we support this. So we don't support, yeah, we basically, only thing that we don't support is variables and functions. That's something I will do tomorrow. And now let's see if this works. I think I have left something undone. Maybe what I'm thinking of is, one thing I'm sure I didn't do is this. Because if we do this more often, no, we only do it once. That's fine. We don't need it then. Okay. Actually, now that like doing variables like this is like an optimization really too. Like it's not only code practice. because this sometimes allows the compiler to figure out something that it wouldn't, because we assure it an assumption that, oh, we know that this program doesn't change during the runtime of this loop, like of this like code piece or whatever, code path. So we just skip this as one field. So then the compiler knows it doesn't have to like refetch it or whatever. Sometimes it's intelligent enough that it can know that, especially if the thing is not volatile, because you can like mark something as volatile and then it's like super aggressive with like rechecking. If we don't, it isn't as much aggressive, but this can still help. It's something I learned from the Mike Acton, one of the Mike Acton presentations, speeches, or whatever. So recommend that for sure. Okay, let's see. Well, maybe I should add like a random native all 5. Something I should do, I think. That would be neat. I also want to add the PCG randomness to the engine, because I don't think I use it right now. I think I use a different, I use like a LCG generator. Let's see, actually. So in game state, we have like, oh, random. Is it like series or synced seed is what I use? Yeah, it looks like an LCG. Random get between, random get. Yeah, this is just an LCG. I want a PCG. Random max times 2. Modulo. It's like, this is decent, right? Maybe instead of random max, we should patch the random max here. Maybe that gives us better properties? Question mark. So we done later modulo anyways, but I don't know. This is an LCG, so I don't really know, but I want to replace this with a PCG. So PCG is like an improved LCG generator randomness. This is the official website for this, but let's see Wikipedia. Pre-permuted congruential generator. It's something that I saw Casey mention on his Handmade Hero. It has much better properties than an LCG. It's way more actually random. It's way less patterny. But I know that like you have a randomness and you modulo it by some number, right? Most of the good properties vanish anyways. So I'm curious if like if there's something that should be done about that. Modulo. Yeah, I don't know. This each modulo like mutates the line. Another thing I want to have as a native function eventually when we have native functions is clock, just time. So we can actually measure how performant stuff is inside of the language. Hopefully that helps. And then we also will need clock for just like timing stuff, right? Like for triggers or whatever, even for AI. I mean, we'll have a wait function, so that should be really good. Something I should note is not here. Kairos. So one thing here is explicit. Yeah. One thing here is so clock and randomness PCG functions. Add native functions random PCG clock real seconds, and I guess ticks. Measure real seconds, measure ticks, right? PCG. Okay. The added units already adds short circuiting is soon. Control flow I think is done. We'll have to test it. But I had some other thought I wanted to know as a feature. Too bad I just can like see my history of my thoughts. That would be useful. Okay, so now jump if true. Oh yeah, there's a problem with this, I guess. Is that it pops the value, right? You want to peek it. Peak the value. And the reason is for and or. And we want to pop the value for other jumps. I don't know. So let's say in the compiler it's like bool. I don't know. Actually, no, I'm not doing that. I want to pop here. I will add 2 new jumps, which is and short circuit and or short circuit. Right. And the difference is they will and short circuit and or short circuit. And is for false and this one is for true. Right. You might want to do things here that are different. So I think what I want to do is like, I actually want to pop this value, right? I want to pop it. Runtime is true. Runtime value result equals nothing. Result type equals runtime type. Integer. Result equals integer equals this, right? Value. Say runtime push value result. Runtime result. It's a bit weird that we and understand the logic here because it's like we are copying here anyways. I think it would probably be like if I do this pointer, do I lose? I mean, I lose on code style because I have to now extract this variable. I can like, if you see here, I can just do this. Or can I? Yeah, that's wrong. But is it? Yeah, I'm biting code. I'm biting it, I'm biting it. I guess I'm also chewing it. Can we also do this here? Pop this value and we push a boolean value. Okay. Okay. Yeah. So that does it. So now in the compiler, when we have binom, we have to switch on its type. Switch. The statement, binary up. No. Case, next token type, and special cases for and or. And default is this here. Then those have a slightly different ones because they have jump, exit jump equals segment, push jump, code, and then opcode is this is answered circuit, right? And we patch this here, segment patch jump, code, exit jump. I guess I don't have to switch here. You can do this like this, so if the statement up here equals end, we do this, and otherwise if it's equal or we do something else, and then exit jump. Maybe it's S64 minus 1. Or maybe I do bool patch jump equals false, patch jump equals true. Like this, and now we need this exit jump to be equal to something, and we say exit jump is equal to this, or to or short circuit, right? Okay. And by the way, this stuff I had noted here, like the pseudo bytecode was here. Eval A, if false, pick A, if false, then pop A, and push false. Yes, yeah. So I always pop and push a value, so maybe I don't have to. We'll think about it. But this is basically how it works. So it's almost handled. Now if patch jump, then we just patch the jump segment, patch jump out, and the exit jump is when we patch, right? Now this whole switch statement can fuck itself. Okay. I don't really like this code structure at all. This can technically return 0, so what I would have to do is like S64 minus 1, right? Do this, and now if exit jump, fuck me. If exit jump is a minus 1, then we just pass it. That works. Have to be S64 because we default to minus 1. Yeah, this looks cleaner. And now in the compiler, I need to, in the runtime, I need to change one thing about this short circuit stuff. That's actually here. We peak the value, right? Peak value 0. That's what we will do instead. Now we'll only pop it if runtime pop value here, runtime, right? And we can even do. Can we do it like this? Is my question. I'll experiment in a sec. To the jump, and we'll say this. And this is basically returning the result yearly. And this would be the value, right? Can do the same here. And I could technically just say that this is always false. And then this is always true. Like this. That's so we don't have to call this twice, and we don't have to cache the result too. Either, I mean. We could, maybe. I don't know. We pop the value, we push the result. Okay. So now let's test this, and I guess I can't test it unless I say how do I test this? I need expression statements actually for this. So let's work on that. So let's go to parser. We'll say extract expression, right? We'll have another enum expression type. Confine it. Just like that. Actually, that's funny because function is a statement and function call is an expression. So that was a fuck up on my part. Now all of those will become expressions, and we'll have a statement type expression statement. Because the thing about expression statements is that they actually have to pop one value out of the stack. So they execute a series of expressions, and then they pop the value. So it's useful to distinguish between them. And I think the best way to do it is by also doing this type separation here. Into function call maybe. Okay. Now struct expression has expression type, right? It probably needs to have a link. It has a result type, and I guess can have a token too for error reporting. And now what we need is a union of things and expressions here. So function literal is actually a statement. with here function call though is an expression. Okay, and now nothing works as expected. Not even here. Static void compile expression. I'll do compiler first because it's relatively small amount of work. Expression. Should have pushed my stuff as one thing though. We'll do if now expression return, but then segment code equals program code, right? And switching on the expression type, we just say this. And now the default. We don't have to have a default, I guess, for now. I enabled this handy feature that I didn't used to have enabled and allows me to only replace what I have selected. I think that's useful here. Say it like this. Compiler error. No, I'll just say token. Next token. That should allow us to pass it token like this, right? Do we not have compiler errors anywhere else? We do. Compiler error twice. Oh, I also fucked this expression. Shim print. Print is a statement that's false. It's an expression because it's like any other function call. Print. Yeah, I will have a list of expressions. Those will also have expressions. And a condition is an expression. Then an else or a statement. Condition is expression. The value of a declare is expression, expression. Okay, function literal is just a function literal. Okay, and now do we have any other problem here? This should be compile expression. Should also be compile expression. And I guess scopes to compile statements. And now what we will need is the expression statement, which we'll add here. Expression statement, and it just has an expression like this, XPR. And all this does is it wraps an expression, compile expression, and its program, and then statement, expression statement, just like that, right? And XPR is what I have called it, right? And now all this, right? Read expression. All this code should do expressions instead of statements. Push statement. It's now a push expression. That's what we need. Expression type, and a result type, right? And now statement doesn't have the result type anymore. Statements don't return things. They don't have a value. They are just there. And then the default value is an expression type value. It's an expression. Right. Push expression. Actually, kind of neat that if I would be to write statement type assign, it will error check it. That's something I don't think I have appreciated about C++ enums. The strong typing of them. It's just because like I hate the fact that I can't like +1 this. I'd have to like make this U32 or something, and then +1 it, and then cast it to expression type. Right? That's sometimes useful, but I like the fact about the type compiler warning me about using the wrong expression. Yeah, expression is what we have here. Expression. Actually, result type is meant to be result type here. That's probably not even true because we'll resolve types on the next stream, I think. I'll do type resolution as a separate step. That way we can have late bound globals. And that should allow us to add variables. Although I could probably start working on like local variables first and ignore globals completely. But I think it's like a necessary step to do. Be done with it. I think that's good. Okay, this is actually an expression. Like this. Now read primary actually returns an expression. Now everything here should replace expression, so statement type, right, with expression type. Statement type. Right. Okay. Okay, and now also replace just statement with expression. Expression should give us an expression. This should give us an expression. Also here, read expression is an expression, read statement. Okay, expression, statement. This is an expression. Okay, this is an expression. Arg expression. Yeah, this means this needs to have an expression, right? This, I think, is used, or is it not? No. This actually is unsued and not unused, I guess. I'll add 2 question marks to see if we can check if that's still true. Okay, and now expression is what we have here. Push expression. Let's just grab all this code for expressions. Let's replace statement with expression. And big case statement with expression as well. Okay, I should mostly do it. And now, let's see, we have functions. Here, function result type. We'll start this result type and in the function literal itself. Say runtime type result type like this. should be good enough for us. And this actually is a sign statement. Okay, and this reads an expression. This is actually a statement. Statement. Expression statement equals push statement arena statement statement type expression statement. The token is token, I guess. Identifier. What do we have here? We don't have anything. Let's just say like parser lexer next. So whatever read expression reads first is our token, I guess. That's how we will do it. Push statement is parser arena. Okay. Read expression, and this actually can just be said like this. Expression statement. Let's say result, because saying expression statement 2 times in a line is very fucking excessive. Okay, now read scope is runtime type none, right? So as you can see, it always just had runtime type none, and outside of like function call, function literal. It's actually even like stupider that I used that. I was me being confused by this system. I'll read expression. This is just an expression actually, and now this is declare function type. No, that doesn't seem correct. Okay, I see. Okay, so right, function literal is also an expression because it actually returns its result value is yeah. I'll have to fucking think about it, but on its own, this is not an expression. Yes. I have to restructure this guy. Let's actually first do like print. Void print expression char name s32 depth. So this is just a mirror function. This works on expressions. Return will have this as here. Also have this, and we'll now just take everything that isn't. So first, let's actually convert those to print expressions when they need to be. So say statement. We'll make them expressions instead, and same for lowercase. Should mostly do it. This will be expression. Okay. Mostly does it. Function. Yeah, it's because function is an expression. type, right? Move it above function, call maybe. I don't know. I don't like that they are not the same order, but whatever. Like just OCD. Expression type function. So this is just a literal for a function, right? Function here. Function call here as well. Okay, expression, and that does it. It's funny because it is an expression containing statements, which probably means I have to pre-declare statement, and I already do. Okay. Print expression. Okay. Right, expression type function, this works. This does not have to have this. Also, wait, declare result type. Yeah, this doesn't have to have this value. Value is actually an expression, read a sign. Oh, I see. So this is a sign expression actually, and it's meant to return an expression. That was me being confused. Okay, so this is expression type function, and it's result type. So push expression. Its result type will be result type runtime type something. Function, yeah, it returns a function. Works for me. Expression function, and now this is actually meant to be an expression. So what I will do, so I'll duplicate this, we'll have expression equals this expression. Now expression statement will actually be something that we do in read statement here. This is what we have. Expression, and now if it is here, then we return result, otherwise we return 0, and we just do expression statement. Result, so result equals result push statement. This return result is good. Result equals push statement, expression statement, parser next. Read expression, right, okay. So this refactor should be almost done here. Now here we just remove all those runtime type nonce. Right, and this should actually be function. This is not a fucking statement, it's an expression. Expression. Okay, now expression result. Yeah, that's fine. Type. Now I should make sure I don't do something stupid. No, this is just a sign expression, but with function, with the function syntax, and want to now. I think I compile now. Not yet. It's because I also have the pre-declare expression like this. I'll actually grab them in opposite order, I think, because maybe that doesn't actually make sense. I don't know. When I declare them in that order. Now let's do that. The code structure in the parser file is also expressions at the top and statements at the bottom, so I think that makes sense. Okay. You know, it's like statements own expressions for the most part. I guess some expressions can own statements, but whatever. Read statement. So now when we have assign expression read, the runtime type is a function, but then you no. So the type scoping I'll have to move tomorrow to resolver. And that should do it. Now this result time, yeah, this is in the function now. And this returns a runtime time function, which is correct. Okay. I also will want to flatten this variable. So in type scope, I'll want to flatten those two into one array. Yeah, we'll actually want to write a hash map for those. Okay, let's see if we work still. Print then expected statement or an end of scope. Whatever. Let's fix that expected statement. Expected state. What? Definitely there's a bug in runtime because expression. So expression statements should emit a pop instruction. I think I have pop or pop n yet, so we'll say pop and pop n because we need to pop the Necron. He's not allowed. We'll now say pop opcode pop equals just runtime pop value runtime like this, right? And then we'll also have pop n, which does, let's say, I guess u8 is fine. This n equals runtime read value, read u8, runtime. And we'll just pop it the end time. Just like that. I must be really sleepy. I don't know what's broken here. U32 E equals 0. Oh, I see. That's funny. I wrote if instead of for. Okay. And now in compiler, when we have expression statements, we also want to segment push u8 will be code. We'll say code pop n. Just pop actually. His expression statement wants to pop the result of the statement from the stack, since that just means expression statement is basically I will run an expression, but I will ignore its result. Yes. Okay. Okay. Yes. Okay. So now what is the error in the parser? Expected a statement or an end of scope. Expected a statement or an end of scope. I think what this means is that read expression, return null. Let's see what happens here. Right, we come here, go here, go here, go here, go here, go here, primary. Right, now we go here, 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 and we go to print. Result is something. Expect the token, we do this, this. Okay. Return the result. Return it as expected. Right. And now the expression is something. Oh, I see. Here the result was shadowed, so it didn't return it correctly. I should use debug because this is fast enough that I don't get penalized by using debug. And when I run Antikythera in debug mode, nothing works. Unsupported type 8. Interesting. Attempt to pop a non-existent value. Interesting. I see what it is. I see what it why it is, because print is an expression, but it doesn't actually push a value to the stack, and it should. So what print should do is runtime. I think what I want to push is runtime push value, runtime result, and we'll create the result. Result is of type runtime type integer, and it's runtime value, and the integer value for it is just to print. Okay. Attempt to pop a non-existent value. Scope unsupported type 8. Scope unsupported type 8. Interesting. I think that means, wait, unsupported type. Oh yeah, that's just expression statements. Should say print expression. Expression statement expression. I'll say expression statement. Statement. Okay. I don't like how that ended up. Oh, I also shouldn't do this. Let's see what happens here. Okay. Oh, thanks. It's that probably means a parser error then. Expression statement. Okay, expression statement expression equals read expression. Oh. Shouldn't try to read it again. We already have it. And now we have something even worse. What is the value? The string. Yes, that's correct. Printing strings is wrong. It's just wrong. You can't do it. Although that was debug print, right? Or no? No, this is execution. Okay. The reason is we need to. So what we need to do it is we need to pass this an arena. So what is this? Okay, so this is AST arena, right? But we also want a data arena. Like this. AST temp stuff. Or whatever. Doesn't have to be that way. Let's call this AST arena, that's fine. It makes it clearer. And then this is data arena. Data arena is just a data arena, which will be a parameter arena. Data arena, right? Hey Myriad. What's up? I'm doing some. I'm writing the programming language for Antikythera so we can have AI and we can have triggers. So hope that excites you. There's a lot of boring technical work, although it's not so boring for me. I get to learn some new stuff, so it's pretty engaging, I'd say. Although sometimes annoying with how Visual Studio works and how this language works, but that's fine. I can do it. Okay, so now what we want to pass it is the program data arena, I think. Yeah, the data arena. And now what we do is each time we push string, we used to push it to data arena. But we'll now push it to we used to push it to AST arena, we'll now push it to data arena, pretty sure. Though maybe not for declares actually. Let's think about it. So this is yeah, let's undo. Okay. Let's think about each case individually. So I think most of the like identifiers I will want to compile to just offsets. So I don't think I need them. But then strings I need. Because strings are actually gonna be used for prints and stuff like that. Parameter names, not really. This is all supposed to be precompiled. Declare name. Not really. Yeah, so actually this is all this is used for is just strings. It's just strings. Yeah, I think I have looked through all of this. Yeah, okay. So now I hope we'll say else. Yeah, okay. So basically now we, instead of having this in AST arena, which we clear after compiling the program, we have it in the data segment of the actual program. And now what I want to test, because we haven't tested yet, is if so actually this code here, I know actually it doesn't run because we don't have variables. But let's say, so I guess that means we only really have permaloops, which is kind of some fun. Should just print forever, right? And then if I write while false, it should never print. Okay. Okay, so we have while loops, although, yeah, they are not exactly useful without variables. Yeah, variables I will do tomorrow, so let's have this in the to-do list. We have short circuiting, we have control flow, we don't have variables. What we want here is I want make type resolution its own pass of the its own pass after parsing, so we can make globals made bound. Okay. And then I think that's mostly it. The rest is like figuring out implementation details, how I want to handle stuff. So I would want probably to have like stack allocated dynamic variables. But I don't know, we'll think about that. But yeah, that's mostly it. I'll say native functions as well. Let's do that when we are added. But yeah, you can see myriad, and we have something. We done exactly. It's massive. It's really just massive because compared to what it used to be, was just like a object oriented more or whatever. It's not exactly object oriented style, but it's like memory wise, it reminds me of that. It's where everything is like allocated and you like reach billions of pointers. So actually evaluating stuff was really slow. And now this is just like a string of bytes that gets evaluated. And this structure, the linear structure, also allows me to do asynchronous stuff. And asynchronous stuff, I actually don't know how performance limiting that will be, because each async runtime will have to have its own stack and its own call frame and all of that. But I don't know. I know that the byte thing is massive. And the thing that the guy from the book had, I think it was still 3 times faster than Python, which is pretty funny. I will have to do some optimizing on the abstract syntax tree before I actually compile, because there's some redundant work that doesn't have to happen when the program is running, and that can happen already in the compiler when the compiler is running. So like if you say 3 plus 3, we obviously know that it's 6, right? We know it's 6. We don't have to run the program to know that. But if we say like sum var plus 3, we might not know that, because okay, if sum var is actually a constant, then we do know that this is 12, by the way. But if this is not a constant, and it's like something, it's like, I don't know, 3, but then it's like while, I don't know, there's like some, let's say this is like a global, right? And this global gets modified, so then we don't know if this is 6. It might be, but if the global was written to, like maybe on some like if something was killed or whatever, we would set it to 6, and then this would evaluate to 9, right? So not everything can be calculated in compile time, but what can be, we should calculate, because then that means we don't have to steal frames. We don't have to steal FPS from the players who just want to fight a competitive AI. So yeah, I think that's something I need to do. And yeah, there's a lot of progress done. It's really neat. If we handle variables and functions, this is like almost good to go. I want to have for loops. I want to make everything robust on the semantic side too. Yeah. I need to add casting. Yeah, it's really. I think it's really useful that I did like the daily streams so far. Probably wouldn't have done as much as I used to like really cram work, where I would do like 9 hours of work straight when I really felt like it, but then I wouldn't feel like it for a while now. That way, and now I just like do a few hours of work. I wanted to do only hour today, but I already did two anyways. So that's funny. Funny how that works. And so in total, I have done like this is I think ninth or eighth day of streaming. I think it's ninth. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is actually 10th stream in a row. So that's pretty epic. Or no, wait. There were actually 2 more streams? 9 days ago, 8. So wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12, by the way, streams. Yeah. And each of them, oh, never mind. One stream was actually repeated. So we have 11 streams. Really. And each of them had like from an hour to 3. Actually, one is even 4 hours. Yeah, it's pretty good. And yeah, we almost have a language that we can run in the game and actually have, like, when we actually can have competitive AI. And yeah, I think that's decent. Also allows me to read the compiler book. I almost finished it, although my reading retention is sometimes still pretty bad. But I think it's good that I am able to read that book. It gives me some insight, especially to the bytecode. I would have had no idea how to actually do it, but now I mean, this is not exactly how he did it, but I use the whole stack system, although I might revise it to be more dynamic than his. He also does like garbage collection, other like dynamic fucking Python stuff or whatever, which I don't want. But, you know, a lot of insight, especially like the semantic stuff with like the stack structure and like the jumps. I sort of knew how to do jumps, but so seeing him actually do it like I thought it would be done kind of cemented that I would do them that way, and they work really well, I think. So this is like a pseudo assembly, you can think of it. It's normally programs run in assembly, but this is like simulated assembly. So really, it's like the guy described this in the book. He described it that you're running a simulator for imaginary ideal architecture. That's how he called it. It's pretty funny. It's funny because that guy is sort of pro OOP, although like not like a fanatic or whatever. But he's like sort of pro OOP, but he also like recognizes all the performance stuff. So it's sort of refreshing to see that. It's usually not how OOP people think. He also doesn't seem like hardcore OOP. He's not like, he doesn't seem to use all of the really bad stuff that I was seeing. His book is actually, so his book is craftinginterpreters.com, and you can read it for free. Though you probably won't, Myriad, but this is like it. It's pretty good book, I'd say. I'm like at 25 and the chapter 25, and that chapter actually I have to completely reread because I didn't really understand it. It's like this concept of up values that is pretty hard to wrap my head around since I haven't done functions yet, really. But once I do, I'll probably read about closures. I don't think I'll have closures. Maybe I'll have closures, non-heap allocated closures. So I would have open closures. That's how he calls this. And yeah, wouldn't have closed. I might have struct closures. Also, this guy apparently also did game design patterns. It's another book that he wrote. And this book I actually have read before, at least fragments of. Yeah, probably does. I realized that most things. Most people would not be really, like, most people will not really understand what I'm talking about when I'm here on the stream, but I'm trying to, like, sometimes explain it more from first principles or whatever. It's probably, like, information retention is probably pretty low for most people when I talk technical, but doesn't really. Maybe that's like. Maybe that's still something that's useful for people, or this interests them a bit or something. This guy just like oop style or whatever. But he's like fairly critical of the patterns too, and he's also very wary of optimization. So I kind of like this book. It's like if I had like a hardcore oop friend, which currently I don't think I have. I think I converted all of them. But if I had a hardcore oop friend, I'd probably show him this, because this like sort of shows how you can also have performance even if you really can't teach your oop. He also has this pattern bytecode, which is actually about writing a language. It's pretty funny. One of his design patterns is you can write a bytecode for things. Yeah, he has this. Actually, this is funny because bytecode is sort of like what AI script was, because it's like sort of resembles this, but it also only had constants, didn't have variables, and it also wasn't compiled, so you like wrote directly in the bytecode. You compiled a non-structure program directly to the bytecode, and here we like compiled this like structure program to do an abstract syntax tree, then we will resolve types, and then we compile it to bytecode, and then we execute the bytecode. So there's many stages. And it allows us to make the language really robust. Allows us to make it less error prone, faster, stuff like that. So I think that's really good. Good approach. So yeah, probably recommend those two books. It's a bit OP. But it also like covers like tagged unions, for example, whatever. Of course, you're like someone's not a programmer, then probably don't recommend it as much. But yeah, something. I'll probably read this book after I read the compiler book, because I have read chapters of it, but not everything. I know I read about like Singleton. I know about Observer. I mean, I know about all of them, I think, but I don't. Maybe not subclass sandbox or whatever service locator. But like reminding this whole thing is probably useful. So yeah, we have some work started, and we'll try to finish as much as possible tomorrow. Variables will be need. Type resolution will be need. Functions will be need. And I guess what I can say is add async. What I can do eventually. And this is sort of, I think I did like, yeah, I split expressions from statements and on expression statement. Yeah, it's like specific assign expression make function calls work on the literal, not a name, make function literal. A type instead of a specific assign expression. I'll make that just means literal a value, which already is, but yeah, it's something I have to do. Work on a value, not a name. Okay. Make functions variables use the same storage. Make functions use scoping that can't be later written in the program. They restrict to global. I guess what I can do tomorrow also is, I mean, this is not as much bytecode specific, but I guess add caste, add explicit. I already added it here, so maybe I just have it here. Yeah, native functions that can be replaced here. Decided we need for loops, ternary, async. Make sure to not return stack allocated variables, whatever. Another thing I can add here is like a substep is add stack. Or maybe not. Have it here. Consider making stack dynamically sized per slot, so we can allocate strings and structs, strings, arrays, and structs, and probably also have move semantics for return. This might be a kind of form that I don't want to open, though. I have to be careful to make this here to not open a can of worms, since here we can't really assign to globals, for example. Really weird. Okay, I'll live here. So yeah, thanks for watching. Who was here, and I'll be here tomorrow again. We'll do like variables and stuff. I think in a few days we'll be able to actually run some AI, so that will be pretty cool. We'll finally have something good. Like once we have those, we can pretty much start adding AI functionality to the language. And oh, another thing I wanted is, yeah, I remembered, add time literals. So like 60 seconds equals to, or I guess for example 60 seconds, 24 ticks, or 24 ticks, 1.5 minute maybe. I don't know, 1 hour, whatever. That would be useful. Which should convert to an integer n tick rate in tick time or whatever. Integer in ticks, which should convert to an integer in yeah, that was something I wanted to note. So that's useful. I did. Anyways, I'll see you guys tomorrow, or whatever, whenever. I'll be here tomorrow for sure. So yeah.